Okay, so in this video, we are going to take a look at some more logarithms, this time logarithmic functions. Okay, so we've already seen logarithms as notation. Now, I want to just start off with a quick introduction. First of all, let's consider a function f of x equal to 10 to the power of x, right? So that should be something that we all know. Okay, it's an exponential, isn't it? It's going to get increasingly big as x gets larger and larger. So what about if we just quickly work out x1 and f of 1 and f of 2? Well, that is going to be 10 to the 1, I guess, which is 10. F of 2 is going to be 10 squared, which is 100. Okay, no surprises there. Now, we haven't seen this yet, but let's now think of logarithms not just as notation anymore, but as an actual function, right, that we can input values in and get outputs. Okay, so if I put in, for example, a 10 into the log base 10 function, right, we've defined g there, look on the right. So what is it I raise 10 by? To get 10, that would be, wouldn't it? I'm inputting 10 as x. Well, of course, what is it I raise 10 by to get 10? It's just going to be 1. What about if I said g of 100, right? So log base 10 of 100. What is it I raise 10 by to get 100? Of course, I raise it to the power of 2. Now, do we notice anything there, look, about f and g? Well, of course we hopefully do. If I input a 1, right, okay, I'm getting an output of a 10 in that function. When I input a 10, I get an output of a 1. Look at that second one. When I input a 2, my output is 100. But if I input 100, my output is a 2. So what does this mean? It means that they are inverse functions of one another. And we already know some things about inverse functions, right? So let's come back and take a good look at this. So here we are again. Look, if f of x equals 10 to the x, then its inverse function is log base 10 of x, right? Okay, and this doesn't just work for tens, of course, right? It is going to work for any value, okay? A to the x has a log base a of x as its inverse. Now, geometrically, let's just take a quick look at this picture in a bit more detail and think about this. So we've already seen from a previous video what an exponential function looks like, right? It gets increasingly big. It's that top left diagram there, look, and it's going to go through 0, 1. So we know something already about inverse functions, and that is that they are a reflection of the original function in the line y equals x. So if we know that, then we can work out the shape. You can see it there. Look, I'm going to draw over it in blue. That shape is the shape of a logarithmic function. And if it went through 0, 1, the original, then 1, 0 is going to be our intercept point there. Look, and if the original had an asymptote at y equals 0, then a logarithmic function has an asymptote there at x equals 0. Everything has reflected in that axis. Now, from there, what we can do is we can combine all that with our knowledge of transformations to think about what these things are going to look like. So just for example, if f of x is equal to log base 10 of x, then if we think about f of minus x, what that would look like, well, that would be a reflection in the y-axis, just like it always is, okay? That's log base 10 minus x. Although there is a sticking point to that one, which I might come back to. If I have minus f of x, which, okay, is minus log 10x, well, that one there is going to be a reflection too, but in the x-axis. And if we, again, have f of x minus 2, so log base 10 x minus 2, that's going to be a shift to the right, okay, of 2 spaces, just like we've seen in previous videos about transformations. Okay, so let's take a look at a function like that. Let's try and draw it, shall we? Okay, so first of all, to help us to understand what this looks like, we're going to need to get used to it. Now, I'm not going to do this every time, but let's just draw out. There is y equals 2 to the x, look. Okay, and I know that one. That maybe could be a starting point. So if I am going to want to draw y equals log base 2 of x, well, what I'm going to need to do is I'm going to need to reflect that, look, something like that, crossing there, look, at 1, 0 in that line y equals x. Okay, that's the first stage. Right, so now let's take a look at this. Well, we've replaced our x with an x minus 1. So with our knowledge of transformations, that means it's shifted across to the right one place, right? So I'm only interested in that blue part now. So let's draw that one. So if it's shifted to the right one place, and originally, I'll draw it in, look, we had that asymptote line there. Well, now we've got an asymptote line there at x equals 1, okay? So now if I want to draw my function, it's going to look like that. And rather than crossing at 1, 0, it's moved to the right one, it's going to cross at 2, 0. Okay, final thing we're going to do is we are going to look, and now the last part is we've added 1 to it. Now, it's going to be hard to recognize what the difference between the look here, because a shift up of 1 isn't going to affect the shape very much. Let's draw it out, though, to make sure we've got it understood. So we've still got that same asymptote line there, look, right, at x is equal to 1, and we've still got the same shape here. But perhaps the only way I can explain this is to say there is a point here, look, at 2, 1 that we know is on our equation, because that original point that crossed the axis there, look at 2, 0, has shifted up 1 just like everything else. Okay, so that is the shape of the graph. Now, I'm just going to say this verbally. What do you think the range and domain are going to be? Well, the domain is going to be x has to be greater than 1. Okay, and the range is going to be that y belongs to the real numbers. We can have any output, but we can only have inputs that are greater than 1. Okay, let's carry on. Let's do perhaps another question. Let's have a look at this one. Okay, this looks like a very complex question, so we'll try and think about how to get from an original log graph to this. Right, okay, so I'm going to start off a bit like last time, although we'll perhaps skip a stage, yeah, okay. This is the graph of y equals log base 5 of x. They all look the same. It's a reflection of 5 to the power of x, okay, in that line y equals x, which I've drawn. We know the asymptote has to be there, look, at x is equal to 0. Right, so what's going to happen to it now? Well, let's think about it. What happens first to this function that's defined as f? Well, we've got this minus 2. So what is that going to mean for our graph? It means that rather than our asymptote being at x equals 0, we're going to be shifted to the right. Our asymptote is there, look, at x is equal to 2. So if I wanted to draw, let me use the same colors, look, okay, our function is going to look like this. This is log base 5 x minus 2, okay? Perhaps we could mark that point because we do know it at this stage. That's going to be 3, 0. Okay, what next? Well, we've got a minus sign, look, in front of it, okay? So what will that do? Well, if you remember your transformations, minus f of x is going to be a reflection, but do you know what axis? It is going to be a reflection in the x-axis, okay? So if I was going to be drawing, where should we put it? Let's draw it over here, look, okay? So if I'm going to draw this, it's going to look very similar to the one above. We've got the asymptote line there still at x equals 2, but we are going to reflect it in that x-axis. So it's going to look like this. Right, okay, we're still crossing at 3, 0, but we're just coming at that asymptote from a different direction. So this is minus log base 5 x minus 2. Okay, final thing, let's go back to the question. We've got this positive 1 as well. So what is that going to do? It's going to shift everything up one place. So let's try and draw the final function. Now, again, just like in the last example, you're not going to see much of a change in the shape because moving that line up doesn't really do much. Okay, we're going to be more like that, I guess. Now, I don't know where it crosses using our knowledge we've figured out at the moment, but I know that if I've moved up one place, there is going to be a point that was at 3, 0 that's now at 3, 1. So this is the function 1 minus log base 5 x minus 2. Now, very quickly, let's just again talk it out and think about the range and domain. The domain of this, the inputs allowed, well, if this asymptote line here is x equals 2, our domain is going to be x is greater than 2. Our range is going to be y belongs to the real numbers, because we can see clearly that every possible y has a corresponding x. Okay, hopefully you've understood how we can apply some transformations to some logarithmic functions, and you've had experience looking and drawing and finding that range and domain of some different log.